So this time what we're gonna do is the weighted moving average. Okay, so as a first example, I'm gonna do 3-period weighted moving average. What is it? Weighted moving average is essentially just a moving average. However, we are assigning different weight to different period involved in calculating the moving average. Okay, so I think you should take 3 steps to do any of these problems. A weighted moving average. First, you need to determine what's the weight. Okay, so the first thing I want to do is I'm going to say period involved. Okay, and you have a weight here, and then I usually like to convert it into relative weight. Okay, the period involved, it's 3-period, right? So starting from immediately before and after, 1 before, 2 before. Okay, so you're kind of generating, creating, producing, forecasting for this particular period. So this is immediately before, this is 1 period before, and this is 2 period before the current period. So this is the current period, and this is next period. Okay, so I'm going to get rid of it. I'm going to just arbitrarily assign weight here. I'm going to weight the earliest period higher than any other period for some reason here. I mean, this is totally arbitrary. Okay, so this weight assignment is not part of assessment. This weight assignment is basically, weight allocation is basically based on your understanding of the underlying pattern. Okay, for some reason, if you believe earlier month should contribute more in terms of generating the forecasting, this is what you should do. Okay, so I like to convert it into the relative weight to make the calculation a lot easier. So 6/10 is going to be 60%. 3/10 is 30%, and so forth. So once we got this relative weight measure, as you know, that the total here is going to be basically 100%. Okay, that's why I'm calling this as a relative weight measure. And with that, let's start to do the 3-period weighted moving average. So I'm going to block out 3-period first, and then I'm going to do the sum product. And first 3-period in this case, and then their corresponding weights. Make sure not to include 1. 1 is basically your total. Okay, and then we're going to absolute reference the weight range so that it doesn't change as you drag it. So with that, let's go down here. Okay, this is what we have. It's always a good idea to double check to see whether you did everything correctly. So it looks like the weight range hasn't changed, which is good news, in 16 to 18. So this is 16 to 18, which is the range for 3-period before the period that's being predicted, which is good. Okay, so before I finish this, I'd like you to try 4-period weighted moving average, just so that you can just use this opportunity to reinforce whatever you learned up to this point. Okay, obviously we're going to need another period weight and relative weight, columns. And then since this is a 4-period, you will start with a t minus 3, t minus 2, t minus 1, t, which is the time point you're currently living in, and t plus 1, which is being predicted, but we're not including this in the weight table. I have a total. Okay, so for this time, for some reason, I just gonna say I want to consider the latest period more than the earliest period. So to do that, you're gonna assign, just arbitrarily, I'm arbitrarily assigning these weights. Okay, and this is gonna be the total, and here the weights divided by the total. Absolute reference this, and go all the way like this. Oops. And then the total should be 1 like this. So then this is the first step. We're done figuring out the weights. Again, this part is usually being provided either in the form of table or just in a verbal description. Okay, so we're gonna leave 4 period out, see if this is what you want to do, and we're going to start use the sum product to get the weighted average. So first 4 period, because this is 4 period weighted moving average, and then the range of weights. Okay, and let's see. So T minus 3 is 2018 quarter 3, right? T minus 2 is fourth quarter of 2018, and T minus 1 is first quarter of 2019. And we're currently living in, say for example, whoever is doing this prediction is currently living in 2019 second quarter. And this person is about to generate the prediction for the third quarter of 2019, which is considered T plus 1. Okay, so I think we're done. Okay, so as you can see that the prediction for the same period can be different. It can all be different depending on what kind of method that you're using, but that's okay. It's meant to be different, okay? Because we can never get the exact number, but eventually we'll find a way to measure which prediction method is the best based on the forecasting errors. Okay, so I'll pause here, and in next video I'll address that exponential smoothing.